Hello everyone, this is INE Foundation Lab 3 and section 6.3 PEC routing. Okay, let me review OSPF and BGP concept and I will come back and code this section. Okay, let's start with OSPF. Let me show this OSPF picture. Okay, in OSPF there are two kinds of areas. One is area 0 and other one is area 1, 2, 3 and etc. Area 0 is always called backbone area, and another area number are called non-backbone area. If I see here, this is another area. We have area 0, this is called backbone area. Then we have ABR and other areas, area 1, 2 and so on. Area 0 is backbone and this is the core of OSPF network and connecting all other area. This is the job of area 0. Area 1, 2 and others are other numbers. Area numbers are called non-backbone areas. And these areas connected to the backbone area to ABR routers, or they are connected directly to area 0. They are either directly to area 0 or they are either connected to area 0 directly or through ABR routers. Okay, this is backbone area and non-backbone area. Okay, then we have OSPF router types. We have internal routers, backbone routers, area border routers, and autonomous system boundary routers, ASPR routers. These are OSPF router types. Internal router, as its name implies, this is a router which all its interfaces are in the same area. This is, if I show this picture here, this is in area, because all interfaces are in area connected to this area. This is called internal routers. And exchange OSPF goes only with other internal routers in the same area. This is the job of internal routers. And then we have backbone routers. Backbone, as its name implies, is a router with at least one interface in the area backbone area. It's is a router in which it's one of its interfaces is in area 0. It's a backbone router. Let me show this scheme here. This is in area, because in area 0 we have routers. This is called backbone routers because one of its interfaces are in area 0. Let me show you this here. If they are here a router, this is called backbone router. Router type. And this is its job is ensure all OSPF area remain connected to the backbone area. Then we have area border router, ABR. ABR is a router that connects two or more OSPF area, including the backbone area. And let's show this diagram. The job of ABR is to connect other areas to a backbone area. This is called ABR. One of its interfaces is in area 0 and one of another interface is in other area. This is like area 1. Let me show you another picture. This is ABR. One of its interfaces is a backbone area and the other interface is in other area. This is OSPF 0. This is I call it ABI router. R3 and R2 are ABIs. And maintain the ABI maintains separate link state database LSTPs for each connected area. And another router type is autonomous system boundary router. Okay, in OSPF, whenever we redistribute another routing protocol into OSPF, that router will become ASPR. This is the job of distribute external route, for example, BGP static route into OSPF. Okay, here we have RIP, and we distribute RIP into OSPF. Then this R1 will become ASBR router type. And user router that connects an OSPF network to external networks or other autonomous systems. This is the job of ASPR. Okay, this is our OSPF router types and OSPF areas. We have backbone area 0 backbone, another area no backbone, and other router internal, backbone router, ABR router, and ASPR router types. Okay, now let's quickly play our area types. In OSPF we have some area types. We first this standard area. In a standard area contains type 1, type 2, type 3, type 4, and type 5 LSAs. But there is no type 7 or NSA LSA in standard areas. This is the regular area that exchange routing information within the backbone, with the backbone area. Yeah. This OSPF area 2 and OSPF area 15 they are standard areas. In these areas we have, let's say, type 2, 3, 5. It contains 1, 2, 3, 4, 5, and 4 and 5. If we have distribution, it contains a standard area. Then we have stub area. A stub area contains LSA 1, 2, and 3 LSAs. Because there is no type 5 external LSA, it's not allowing distribution. Then we don't have type 4 ASPR SAM LSA either, and we don't have type 7 LSA either, and no ASPR allowed in stub area. And stub area doesn't accept external routes from outside OSPF domain, and thus it's reducing the routing table size. But we can configure a default summary route 0000 on ABR to reach external routes for stub area. Then we have total stub area. Total stub area contains only type 1 and type 2 LSAs. There is no types type 3 summary LSA, type 4, type 5, and type 7. Then no ASPR is allowed either for total stub area. This area further restricts external routes and summary routes, only allowing the default route to the backbone. Only default route is allowed in total stub area. There is no summary routes in total stub. Another OSPF type is NSSA. NSSA contains type 1, type 2, type 3, and type 7 LSA. And because we have it contains type 7 LSA, then ASPR is allowed in NSSA. but there is no type 4 and type 5 LSA in SSA. This function like a stub area but allows external routes in the limited manner. This is like if I compare this NSSA to a stub area, it is contains 1, 2, 3 plus 7. This is like a stub area plus its it allows external routes in the limited manner. Then we have totally NSSA. Totally NSSA is like totally stop plus it's allowing type 7. Totally NSSA contains type 1, type 2 and type 7. There is no type 3, type 4 and type 5, but ASPI is allowed in totally stop. Totally stop is like totally NSSA is like totally stop plus type 7 LSA. Type 7 LSA. Okay, these are OSPF area types. Area types. Then we have LSA, OSPF LSA. We have LSA type 1. This is called router LSA. Type 2 is called network LSA. Type 3 is called summary LSA. Type 4 is called summary ASPI LSA. Type 5 is called autonomous system external LSA. 7 is called not so stable area LSA. We can see all of this concept here. And OSPF network type, we have OSPF network one is point to point, point to multi-point broadcast, point to multi-point non-broadcast, and broadcast and non-broadcast multi-access, and so on. Okay, this is the basic OSPF concept. Then, okay, let's review BGP concept. Start this BGP concept. Okay, let's quickly finish on BGP. BGP uses path vector to select best path to the destination, and it maintains a table of routes including sequence of ASs that the table tables. And in BGP session are established over TCP port 179, and there are two types of peering relationship. One is internal BGP, IBGP, and the other one is external BGP, EBGP. IBGP is between what is within the same area. It means local AS and remote AS number are the same, and EBGP between external BGP between what in the different ASs. It means local AS and remote AS are different. Okay, this is BGP path selection. I will explain this later. Between better attribute. Okay, let's just review BGP attribute. Okay, we have BGP attributes are categorized as well known and optional, and further divided into mandatory and discretionary traverse, transitive and non-transitive attributes. In general, we have well-known attributes and optional attributes. These are two main attributes of BGP. Then they are divided into mandatory, discretionary, for well-known, and transitive and non-transitive for optional. Okay, well-known attributes. The well-known attributes. These are recognized by all BGP implementation, and are divided into mandatory and discretionary attributes. Well-known attributes are AS path, context sequence of AS numbers that the route has traversed, used for loop prevention and path selection, and shortest AS path is preferred. This is the example of AS path if show up in BGP. Then another well-known attribute is next hop. Specify the IP address of the next router to reach the destination. In BGP, the next hop is updated to the IP address of the advertising router. But in IBGP, the next hop remains unchanged. In some scenarios, we can change this behavior by next hop set command. If we have eBGP, if we have here, this is eBGP and these are IBGPs. eBGP and these are if eBGP sends this to IBGP and IBGP sends to this another IBGP, then we can use next hop set on this IBGP to change next hop, but to change our next hop for this device. And in between next hop is updated to the address of advertising router, and IBGP remains unchanged. Another well-known attribute is origin. Indicates the origin of the route and its type. This is we have IGP, EGP, and incomplete. IGP it means originated from an IGP. This is most preferred IGP routers. EGP originated from EGP. Implant means its origins are unknown. It's typically due to route distribution. If we distribute in BGP, it will become incomplete. Okay, these are well-known mandatory attributes of AS path. Next up, an origin are well-known mandatory attributes. And another one is well-known discretionary attribute. Well-known discretionary attributes are local path and atomic aggregate. Local path is used within an AS to influence outbound traffic. And higher local path is preferred, and default value is 100 and can be configured by route map and other BGP commands. And another well-known discretionary attribute is atomic aggregate, and it indicates that the router has aggregate routes, and some specific details may have been lost. Okay, second, another attributes are optional. Optional. optional attributes. We have optional transitive and optional non-transitive attributes. Optional transitives are aggregator and community. Aggregator specifies the router and is that performs route aggregation and includes the ASN and IP address of the aggregator. And community is we can tag upload routes to simplify policy management. This is the job of community. We have other community. We have some communities which called default communities, non-export and non-advertised. And another one is optional non-transitive. This is multi-exit discriminator med and originator ID and cluster leads. These are our optional non-transitive attributes. Okay, BGP attribute path. Let's review BGP path selection. First, BGP first select its weight. This is Cisco specific and a higher weight is preferred. And we can use weight for control. We can use weight to controlling outbound traffic. This is we can by this command neighbor remove IP address route map and name and in command. Okay, outbound traffic means whenever data is leaving your AS number, your network or ASS. And inbound traffic means data entering your network or ASS. Inbound means whenever data is entering into your AS, and outbound means when the data is leaving your AS or your network. We can use wait to control outbound traffic leaving your AS, but we have to use in for our route map. We can then second local path. The highest local path is perfect. We can use local path for controlling outbound traffic either the traffic leaving RS by this command. Then AS path, and shortest AS path is preferred. We can use AS path to influencing inbound traffic by this command neighbor remove route map name and out traffic entering AS inbound traffic. Then we have origin. IGP is preferred over UGP and incomplete. Then we have med. Last med is preferred. We can use med to influence inbound traffic by this command in route map. Then it prefers eBGP over iBGP. That prefers the path with the lowest IGP cost to the next hop. Then prefers all this route for stability and lowest BGP router ID for tiebreaker. If we have tiebreaker, you can use last BGP router ID. At the end, it will select lowest neighbor IP address. This is our tiebreaker. The route with the lowest neighbor IP addresses. And this is our BGP path I use for local path. Local path is you can control outbound traffic, data leaving RS, AS path for influencing inbound. Community implements granular routing policies. We can use community for applying our routing policies. And med preferred entry points. Inbound we can use for load balancing. And this is here another AS path. Okay, this is some examples of BGP attributes. We can change, modify our lookup pair. Yeah, we create access list. We create a prefix list all routes. Then create route map. Destina. Then another route map, and this is another prefix list. Then we can set lookup preference, and we can use neighbor route map and out. That's one of this here. Okay, this is our local preference. This is well-known discussion attribute used to control selection outbound path within autonomous system. This is local preference. This control outbound traffic. Then traffic that is leaving our network. And let's see example of local preference. This is how we can upload local path. We can use route map, set our local preference, and set neighbor route map, route map name, and specify in in some scenario we can use out, but most of time we can use in to influence outbound. And so on. Okay, this is basic OSPF and BGP concepts. Okay, now let's configure this section. Okay. Okay, configure OSPF version 2 between 5.6 switch 1 and switch 2 using process ID of 100. Okay, OSPF version 2 5 5 6 switch 1 5 6 switch 1 2 and configure OSPF between this with process ID of 100. And add metal loop pass 0 networks on switch 1 and switch 2 into area this area number. Okay, which means that we have to use this area number for 56 switch 1 switch 2. This is our area number we have to configure with process ID of 100. This is OSPF area number and this is process ID. Okay, let's configure this. Okay, this is we have to use this area number area and process ID of 100 to configure OSPF for on 56 switch 1 and switch 2 and add better loop as 0 of switch 1 and switch 2 into this area number. Let's step out 5. That's for you. Okay, yeah, I have to use this interface. Yeah, 225. This is connected to switch 2 and this is connected to switch 1 and to switch 3. So R and R6. Let's go for this. Interface, this one. IP OSPF. I use I am using interface level configuration, OSPF interface level configuration. 5, 6, 21, 22. Then let's go to switch 2. Sharp interface brief. Switch 2, I have some interface VLAN. This interface VLAN. I have port channel. This port channel. I have to configure on this interface VLAN and this port channel. Output 1 area 5, 6, 21, 22 on switch 2. Interface this port channel number. Okay, interface and add better look back into add better look back either. Okay, let's see. Interface. Back 0. We'll do show output OSPF neighbor. Do show output OSPF interface. Loopback 0. VLAN. Okay, in the previous lab, let's check configuration previous lab. If I do show VIF, this interface is in VIF. VPN A, then I have conquered OSPF for this interface. Do show IP interface brief. Even if I do show run pipe section router OSPF, then it is automatically create this router OSPF purchase of the 100 VIF VPN A. Which is correct. On switch to I have just checked it. This my VIF. Do show VIF. Then my port channel is not in VIF. It should be in VIF in previous lab because it is not in VIF. If I do show down app section router for SPF, because this interface is not in VIF. Interface I receive this error. On switch, I have to receive this VPN specified does not match. I have to put this in VIF. This port channel should be in the VIF previous labs. Okay, let's configure this. I just copy this configuration. switch to show run interface 0 should be we are forwarding between A. Then I have to configure this IP OSPF on this. Done. User VIF and this is Kyle. Click done. On this one, then switch 1. Okay, let's check switch 1. Show VIF. Okay, there is no VIF here. Good. Okay, it's just simple compression. Then show IP interface brief. I have VLAN. This interface and this interface. Okay, config T. Switch 1 ports are not in VIF. Interface VLAN and add vectors and add IP OSPF. Good. Then for do show run pipe section auto OSPF, and it is auto OSPF 100 instead of do show run pipe section with it is auto OSPF 100 instead of auto OSPF BIF in A, because none of its interfaces are in BIF. This is normal OSPF. Okay, then I have to upload channel interface port channel 12. Then I have to advertise this loop back into this area. Interface loop back 0 and advertise into OSPF. Okay, 5 switch 2 switch 1. Do show IP OSPF maybe. Do show IP OSPF interfaces. We're gonna 204 channels. Channel and look back. Okay, now I have to go and switch on R6. Show VRF. We have Ethernet 2.6 in VRF on R6. Config T interface. And I OSPF this one on R6. And do showdown pipe section. What OSPF? Then I have what OSPF one on the BRF ever. This is BRF ever OSPF. This is one on there. On switch 1. Five, 6, switch 1. And 5, 5, switch 2, switch 1, and R6. I want R5, R2, switch 1. Okay, done. It's just done. Just 2 sections are done. Let's check on switch R6. Do show IP OSPF maybe. And this is maybe with this Ethernet. Okay, done. Switch 1 now I have to have 2 neighbors. Before I had only 1. Now I have to have 2 neighbors here. Okay, now it is working. Two neighbor here, on switch 2 I have to neighbor either. OSPF neighbor. Okay, now let's come to another section. Conquer BGP AS between switch 1 and switch 2. And redistribute all connected networks on switch 1 and switch 2 into BGP. Okay, let's do this section here. 103. Type section BGP. Okay, this is I already have this AS number on. Three. Okay, let's start with switch 2. Short on type section BGP. Show IP protocols. There you know what in here. Let's check switch 4. Show IP protocols. No protocol here. Show IP interface brief. Look back. Use this one. Okay. Conflict T. Hotel BGP 65 025. Then BGP. I'm going to hardcore BGP with the ID. And let's check switch for interface. Show IP interface brief. I have this interface here. Okay. Neighbor, this one. Remote AS, because this is IPGP connectivity, because both hotels are in the same AS number. The local AS and remote AS are the same. No auto summary. same here. What a BGP, this one. Conflict here. What a BGP, this one. The BGP what ID should be this one. Enable VLAN. Let's check this interval. 2, 3, 4. So it should be this one. Maybe remove this. This one. Not a summary. Neighbor is up. Do show IP BGP summary, and it is working. Up, and it said at the end and it distributes all connected networks on switch 2 and switch 2 into BGP. Okay, we can use the distribute connected. And do show IP BGP. This is because I have redistributed those routes, then this will become incomplete. BGP. Next up, 0 means it is local generated, and this is parameter access numbers. Originally incomplete, it is up down redistribution. Okay, this is and our last part, compare BGP between 3 and 6 using VLAN, this VLAN number as a source. Let's check R3 here between switch 3 and R3. Showdown part section BGP and R3. show VRF. Okay, this interface is inside VRF. One point, let's check this VRF. R3. Okay. Switch 3. VLAN. Show VRF. Show IP interface. Brief. VLAN. This VLAN. And now 3. Okay, this interface is inside VRF. Ethernet 200.233. Okay, I have to add address family for BGP. Okay. Yeah, to conquer, I have to add another address family on R3. Simply I go to router, config T, address family, IPv4. Then I have VRF, and split our VRF name. This is VPN underscore B. And add my neighbor here. Neighbor. Okay, let's see switch to the interface. Maybe it's this one. Then remove this. 665.0.24. And activate. Then activate this 1 and 2. Maybe unactivate command. So let's conquer switch launch. 5 section. Rotate BGP. config T, rotate BGP this one, neighbor you shall interface brief this one is our neighbor, and remove AS. And up. My neighbor is up. Okay. Fuchsia IP BGP summary, and I have two neighbors. One is this AS and the other is this AS. Okay, done. Okay, before let's check my OSPF root on switch 2 and I'll close this section. Okay, let me check this if I have OSPF is working here. Sharp root VRF VPN and OSPF, and I have two OSPF roots here. And R5 okay. And R5 let's test this with VRF VPN 128 10 216 and 6, and it is working. And switch 3 I do sharp BGP IPv4 unicast summary. So my neighbors between okay, that's it. This is how we can configure OSPF aware routing. Like here we can see here VPN aware, OSPF BIF aware, this is hotel OSPF BIF, and also we have added this family section hotel BGP. Add this family VPN before BIF VPN are on the or BGP. I can see this here, then show BGP IPv4 unicast. Show BGP BRF. I have to spell BRF first. BRF. BRF name, or I'll type star. Just star. And this is my route inside my BRF. Show BRF. Or I can specify BRF name. Show BGP BRF and VPN B. So the routes that I have advertised in my BRF. This is receiving from this yes. 23, 24, and this one. It is for switch 1 and switch for loopbacks. But that's it. I hope you have enjoyed this video and thank you for watching.